Okay. So good morning. We have a couple of things to accomplish today. So first off, I need to stamp your homework, but I will do that throughout the course of work time today. Okay, you know what I mean? So I'll come around. I want to get us going right away on some stuff, and then there's a lot of questions that you are going to have to answer today, like in your tables after we get done talking about some stuff. And so during that time is when I'll come around and I'll stamp your homeworks. We will have a homework for lesson 3 due tomorrow, on unit 3. Lesson 2 will have the homework tomorrow, and you have a formative quiz coming up right away this week, Friday. Okay, so a formative quiz this week, Friday. All right, so we're going to be jumping around a little bit in your books. So first off, this actually starts, or this box here is on page 20. Okay, so we're gonna kind of jump between the start of this lesson 2 and page 20 a couple of different times today. So when we were thinking about this lesson, I said to myself, I want to talk about inequality and interval notation first, so that you guys understand what we're talking about when we get into the examples. Okay? So if I were to say in words from 0 to 30 seconds, okay? From 0 to 30 seconds would be the words. Written as an inequality, we could write that as 0 is less than or equal to t is less than or equal to, or less than 30 in this case. Okay? Remember, with inequalities, the alligator, or the crocodile, as I call it, the alligator is the less than greater than ones. Crocodile is the less than or equal to greater than or equal to, because their crocodile's a little more meaner. Okay? Eats the bigger of the number. So if we're writing it, this is called a compound inequality, because it's got 2 inequalities in it. And remember, it always is smallest, or the smaller number, and then a variable, and then the bigger number. Okay? And those alligators and those or crocodiles and or there, because like in this one we have 2 different kinds, are always going the same direction. They should never be fighting each other. Okay? Now, that same thing can be said in a much easier method. And that easier method is something called interval notation. And interval notation are always written smallest value to greatest value. Interval notations have brackets and parentheses. Brackets are for the including of that number. So a bracket would be for your less than or your greater than and equal to. Okay? So brackets are with the equal to parts. Parentheses are just when it's not included. So when that endpoint is not included. So that would be your less than or your greater than. Okay? I'll give you a moment to write all of that stuff down. You should be writing all of this down on page 20 right now. this capital U here is interval's way of saying the word and. That's what that capital U means. The drawback to interval notation is that in the case of like that very last interval from 60 seconds to 90 seconds, what does that look like? It looks like a point, right? An x comma y point. So you've really got to pay attention if we're talking about a point in space or an interval on your graph. Okay? With the brackets, it doesn't matter because the bracket, we don't have brackets. We don't use brackets for points. Okay? Give you about 30 more seconds to copy this stuff down. All right. So this is just going to be now we can go back to the start to page. What was it? 16. Actually, yeah, we can do it. We can do it up at the top of page 16. You can just draw yourself a little graph, okay, of these two scenarios in that open space up there on page 16. And then the question that's being asked is, what is the domain and the range of each of those graphs? Okay? To put some context in here, let's add, because it's probably hard for you guys to see in the back. So there's 1, 2, 3, 4, 5, 6, 7, 8. So we're all the way out to 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's negative 9. 2, 3, 4. Up 4. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Do the same over here. I think it's the same. 1, 2, 3, 4, 5, 6, 7, 8. Yep, that's negative 8. 4. Yep, that's 4. 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. Yeah. There is a subtle difference between the two. Does anybody see it? What do you got? So left one has arrowheads on it, right one has dots, right? Okay? So let's talk about that. What do the arrowheads mean versus the dots? What do you got?
The arrowheads means it keeps going, and then the dots mean it stops.
So the arrowheads means it keeps going in both of those directions, up and to the right, down and to the left. The dots mean, nope, we're done, it's stopped. Okay? I would concur. Does everybody else agree with that? Okay? All right, I like it. So what would the domain then be on the left graph? What are all of the x values that are represented? If it's going to continue on in both directions, what are all of the x values that we can put in that equation? Say it loud. We can put them all in, right? Because it's continuous, right? So that means for sure we can use all real numbers, okay? So the domain here would be all real numbers. Now, in interval notation, that would be from negative infinity to positive infinity. And unless your name is Charles Norris, aka Chuck, okay, you can't count to infinity. Okay? So that's why infinities always get a parenthesis. Okay? Right? Infinity symbol is just turned on its side 18. Okay? Range. Yesterday we learned about the range. Domain was our x values that we put in. Range is our what? Our y values. So now instead of looking horizontally where my function is, now I'm looking vertically for range where my function is. What's that? What's the range of this left graph going to be? Remember, it goes on in both directions forever and ever and ever and ever. It would also be all real numbers because it's going on forever and ever and ever in all directions. Now, let's switch over to the other one. Now, this one, you guys just told me that this one ends, right? Okay, so x values, horizontally is domain, x values that we can put into this function. Small to big. What's the smallest x value that we put into this function? -9. What's the biggest x value we put into this function? 8. So this domain is going to be from -9. Are we inclusive or exclusive? Meaning, is it closed dots or is it open dots? Closed dots means we include them, right? Okay? So then we're going to have the equals part to there. In interval notation, this would be -9, 8 with brackets on both sides because we're including those numbers. Okay. Then we turn the range. Range is vertical again. Now I'm looking vertically. What's the smallest vertically my numbers go? -8. Do I use x here? What do I use? I use y here. And what's the biggest that my y values go? Goes all the way up to 4. Okay. I'm going to scroll down just a little bit to get a little more space now. So that one in interval notation would be -8 to 4 with brackets there. Questions on that? No? All right. Let's jumping into Alonzo, Maria, and Sierra are rafting. Anybody ever gone rafting down a river? Sitting in an inner tube and you just float? It's actually kind of fun and a little relaxing. Don't ever forget the sunscreen. Because you'll fry on one side and on the other side you'll be white. Or whatever color your pigmentation on your skin is. Well, you'll be completely red on the front side. I've done it. And actually I haven't done it. But I've seen it happen. A friend of mine once was tubing down the river and was literally completely red on one side and nothing on the other side because they forgot to put sunscreen on. It was bad. You had to take it to the hospital. It was that bad. Okay? So don't ever forget your sunscreen. Alright? So they're floating down in the river in inner tubes. enjoying their day. Always a good time. Alonzo noticed that sometimes the water was much deeper in places than others. Mariah noticed that there were times it seemed to be moving faster than others. Sierra laughed and said, math is everywhere. Because guess what? Math is everywhere. She's not lying. Okay? Learn more about the river. Alonzo and Mariah collected data throughout the trip. Here is Alonzo. So here's a data table for Alonzo throughout the trip. Yes? Okay? As they float along. Okay? Using the data, let's interpret the key things. Okay, so we need to figure out the key things. So we need to know when the data is, or when the depth is increasing, when it's decreasing, what the max is, what the min is, what the domain is, what the range is, what the y-intercept is, what the x-intercept is, if it's discrete or if it's continuous. A lot to get out of this one little graph, right? Yeah? Okay? So you're going to be kind of flipping back and forth back to that page 20. Here's where I don't necessarily agree with the textbook either. They want you to make a graph of this stuff because it's easier to see the data or to get all of that information from a graph, but they put the graph on page 20. Yeah, exactly. That's when they want you to graph it. We're going to graph it right now. Okay? So I'll leave the data up here, and then we'll kind of graph it back and forth on page 20. So if you just want to stay on page 20, that's fine. So first off, what do I need on my graph? I need to get axes on my graph first. Do I need negative numbers on my x value? Why not? What is negative x values going to represent in this situation? It's going to be what? Negative x values. It's also going to help us decide what our x label is going to be. It's going back in time, right? Because on the bottom, or the x values are time, right? What is our time in off of our chart? No, but what's our time? What's our unit? Minutes? Time in minutes. Yep. Okay. So we're going to label our horizontal as time in minutes. Vertical. Do I need negatives on my vertical? No, because what would that be? Negative depth. Can we have a negative depth of a river? No. So what are we going to label our vertical as? Bless you. Depth in feet. Yep. With me?
Yes.
Okay. Looking at our data, I'll scroll back up here now so we can see our data so you don't have to keep flipping back and forth. In terms of horizontaliness, what do you think we should go with as a scale? Tens? Can we get 12 in there? If we went 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Yep, we can do that. Up tens, I like tens. Okay. Depth in terms of vertical scaling. What's the maximum we got to go to? Isn't that 6.5? That's 6.5, not 65. That'd be one heck of a drop off.
12.
We got to go up to 12? So what do you want to go by as a scale on the vertical?
No.
Ones? We can probably go by ones. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, we can definitely go by ones. Okay? All right. Now, we just got to plot some points. Okay? So the first point that we're going to plot is 0, 4. So at 0 minutes, we're at a depth of 4 feet. So we go right there. Next one. 10, 6. Right there. Next one. 20, 8. With me so far? Okay. Next one. 30, 10. $40, 6. 50, 5. Is that what it is? Yep, 50, 5. Actually, I think I can just do this. 60, 4. 70, 5. 80, 7. 90, 12. 100, 9. 110, 6.5. And 120, 5. Everybody should have this graph now. Yes? Okay. We can connect those dots because this is not a discrete case, right? Is this a continuous case? As we're going down the river, the depth of the water is changing at all times, yes? Okay, it's not just, okay, now I'm going here, and it's different. Then I go there, and it's different, right? It's changing, it's a continuous change. So we can connect these dots. Yesterday we talked about the word increasing. Does anybody remember what it means to be increasing? Going up as we're going to the right. So where on this graph is my values increasing? By the way, we can flip back to page 16 now. Now that you got the graph done, I'll leave the graph up here. Okay? So when is this increasing? When's it going up? Let's actually do this. So it looks like we got one here, we got one there. Looks like we got one here, then we've got a section here, then a section here, a section here, and a section here. Which sections are increasing? Taylor, give me one of them. So in the definition of increasing would be the graph is going up as our inputs get bigger. I almost said they're exponents, but as our inputs get bigger. Okay? So give me a section. Section 1, do we agree with that? Section 1 is increasing. Okay? So that would be from 0 to 3 minutes. Right? Which in interval notation would be 0 to 3. Right? Where else is it increasing? Or which other ones is it increasing? 4 and 5, right? Because we can kind of combine those two together, right? So it'd be increasing from, oops, I put 0 to 3. I forgot these were by tens. This should be 30. My fault. That should be 30. My fault. So that would be from 60 to 90. Yes? So we'd have a union there of 60 to 90. Yes? Okay. Where is it decreasing then? 2, 3, and 6? Okay. So section 2 would be from 30 to 60. Oops. Add 6. Oops. No eraser. And section 6 would be from 90 to, what do we go up to, 120? In interval notation, would be that. What is the maximum depth? So the biggest, right? It'd be 12 feet would be our maximum depth. And where does that occur? At 90 minutes? So that's how we would write it. The maximum depth is 12 feet, and that happens at x equals 90 minutes. We don't write it as a ordered pair. Bug flying around that room. I think it's a ladybug?
It was on Marilyn's book, and then
Oh,
and then
there it is. I see it there.
jumped on me.
Okay. What's our minimum? Our smallest value? 4, right? Okay. So that'd be 4 feet, and where does that happen? Just at 0 minutes? And 60 minutes, right? Yeah? Domain. What would our domain be? What are our x values that we have put into this? What's our smallest x value? 0. What's our biggest one? So that would be the inequality of our domain. The interval of our domain would be that. What's our range? What's our y values? Smallest, 4, biggest, yes? Okay. Looking at our graph, what's our y-intercept? So that would be the point 0, 4. This one, remember, is a point. Because that's not interval notation. That's an actual point in space. What is our x-intercept? Where does our graph touch the x-axis? It doesn't. So there isn't one, right? What would it mean if there were an x-intercept? What would it mean? What's the scenario again? No? What does it mean if we had an x-intercept? We'd have no water, right? We would be at, the river would stop, okay, because there would be no water, or the river would have dried up. Okay? Yep. All right. And I thought we got one more. Discrete or continuous, we already answered that one, that this was continuous. Okay? Good? Love it. You have this graph now at the top of page 17. Okay? So this is a graph that Mariah collected by GPS unit, providing the distance that she had traveled over a period of time. So this is distance over time, okay, in minutes. So now you have this picture right here. So let's talk about the increasing, the decreasing, the domain, the range, the max, the min, all that fun stuff. Okay? I got to grab my picture so that I don't have to keep flipping back and forth. So you're looking at the top here now on that one. Okay? What do we got? When is it increasing? When is it increasing? When is it going up as you are going to the right? 17, page 17, 1, 7. This one that you drew all over. When is it increasing? It's always increasing, right? It's always going up as it's going to the right. So it would be increasing from 0 to 120. I'm just going straight intervals now. It's easier. When is it decreasing? Never. What is the maximum distance? Maximum distance. A little bit more than though, right? A little bit more than 16,000, so like 16,500? At an x value of 120 minutes. What is our minimum value? 0? When did that happen? Makes kind of a lot of sense, doesn't it? You start at the start when you start. Okay? All right. Domain of this one, x values. Smallest x value? Biggest x value? Range. Smallest y value? Biggest y value? That 16,000 number, right? Y-intercept. Where's across the y-axis? 0, 0, right? x-intercept? Isn't 0, 0 the x-intercept too? Discrete or continuous? Continuous, right? Because it's connected. Okay? What I would like you to do now, and I'm going to give you 15 minutes, that gives me 5 minutes at the end. Okay? What I would like you to do now is I would like you to, at the bottom of page 17, and then page 18 and page 19 as a table, I would like you to answer all of those questions. Okay? So you're going to be going through and you're going to start answering all of these questions. Whether you agree or you disagree with the statement, and a quick reason why you agree or why you disagree. Okay? Have at it. Video watchers, you can pause now and you can make your selections, and then I will have answers at the end. Unfreeze the screen. Okay? So I would agree here in A that the depth of the water increases and decreases on the 120-minute floating excursion. Did you agree with that? Because the depth of the water goes up and it goes down. Yes? And that was that first graph that we made. I would agree that the distance that we traveled is always increasing. That was the second graph, the one that was made for you already, the curvy one. I would agree that that distance is always increasing. We actually talked about that. Distance traveled is a function of time. Would you agree? The inputs are the time. How much time you spend on the river determines how far away you are from the start. Okay, that makes sense. Distance traveled is greatest during the last 10 minutes than during any other 10-minute span. Did you agree or disagree with that one? I disagreed with that one because of this section right in here is the same as, if not steeper, than that last 10 minutes. Right? Steeper means that you're traveling faster, right? Okay, because your distance is increasing over a shorter amount of time. So I went with no on that one, but you could have disagreed with me on that one. The domain of the distance time graph is all real numbers. I agreed and I disagreed with this one. I agreed with it because it's continuous. So yes, it is all real numbers, but I disagreed with it because it has to be x is less than or equal to 100. That should be a 2. Let me go back over here to the board. Add 2. 20. Because you only spent 2 hours on the river. I agreed with the y-intercept is 0, 0 in terms of the depth. Oh, wait. In terms of the depth. Nope. Sorry, I misread that question. That one should not be. In terms of the depth, no. I do not agree with that one. Okay. Distance traveled increases and decreases over time. We're not at that because it's never that graph, that wavy graph was never decreasing. So that one's a no. Depth of the water is never 11 feet. I have it being 11 feet twice off of that graph. Can't get to 12 without going through 11 in terms of depth. Okay. Range, I disagreed with that because we said it was 16,500 according to their graph. Domain of the depth or of the depth of the water with respect to time is from 0 to 120. I agreed with that. Range from 4 to 5. I disagreed with that because the depth got to, what did it get to, 12? Okay. Distance time graph has no maximum value. I disagreed with that one because there is a maximum at the end. depth of the water reached a maximum at 30 minutes. I both agreed and disagreed with this one because I would call this a local, let me go back over here and write this, a local maximum. Meaning, let me go back to this graph and do not be packing up. So rude. Meaning, it's a maximum, yes, because it's shifting over from increasing to decreasing, but it's not the biggest of the biggest ones. Okay? Have yourself a great, grand, and wonderful